Okay, time to start. We have done a ton of testing. I have a ton of data, and I would try to, when I was getting ready for this presentation, how can I extract just 40 minutes worth of all of the work that we've done and make it useful? So I've got kind of two areas. One is storage performance related, which I think you will find valuable. And in addition to that, it's the type of thing that you may be doing on your own if you engage with Raphael and Dave Sullivan and professional services. So not only, watch what the results I got, you could be doing some of this stuff to help. And we'll talk about that a little more. And the second category I came up with was things we've done to the base operating system that will help everybody in general. And that I think you should be interested as well, because they don't just help the tests that we ran, they should be goodness for the entire system. I also want to say that this was a joint effort. Paul Jacoby, Rob Brooks, Dave Fairbanks, Christian Moser, we all combined to make all this happen with various aspects of the project. A little bit of the objectives that we started out with. And as you will see, we went down a couple of side streets along the way that turned out to be pretty darn interesting, as you might expect happens along the way. Next, move on to what exactly did we do and how did we do it? And then the real purpose of what we started out with was what is the difference between fiber channel pass-through and MSCP serves? Now, the real guts of this was, does fiber channel pass-through really live up to what it's supposed to be? So we have some numbers for that.
Do you have the controls for fiber channel on x86?
All we've done was very mundane stuff on KVM and VMware. Probe, depending on how I'm feeling today, probe is either one of my favorite or least favorite topics to talk about. And as many of you know, we were worried about this from day one of x86. And I have some good news here. We ran into a very strange issue with the clock ticks. It doesn't affect the system running in general, but it surely affects anyone who's trying to measure anything. So this is goodness. And then when I started out putting this together, I didn't have CPU scaling even in mind. But we keep getting questions asked, people want to know, and so I did a couple of pretty crude tests here that I think have some fairly interesting information. So that's where I'm headed. Originally, a very simple objective to start out with. You're going to take your x86 guest, and you want to put it in an existing titanium and alpha cluster. That's kind of the premise that we started with. We figure a lot of people will do that. So what we did. So that's where we started out. And the purpose was accessing an MSCP serve disk, accessing it via fiber channel pass-through, and comparing that to what you actually get on Itanium right to the SAN. So we've got numbers for that. So that's what we started out to do. There were one or two things we've seen from customers that we said, this is really interesting. How can it be this bad? So I took one of them and we kind of pursued that. And then, as I said, we encountered a couple things along the way that turned out to be unbelievably interesting, and we made some good changes there too. So that's my plan. Bottom note up here, with rare exceptions, and I'll point those out, this was all done on version 9.2.3 Update 2, vanilla out of the box. That was our baseline for testing. And notice the underline there. This is still all done with VMS built with cross tools. No native builds underneath this yet. So keep that in mind as well. And the other thing is, I don't want to say your mileage may vary 100 times in the next 20 minutes, but keep it in mind with whatever I say. So what did we do and how did we do it? Part of our QA systems build is something called IOF. There's 100 of these things around. You know, they measure performance, IO, give you back some numbers. This is the one that we used, and I've been working with Dave Sullivan and Raphael, and this is going to be made public so you can take it yourself. Dave will have some instructions. He's got a rap sheet to fill out with data about your environment. But when you see things that I do with IOF, you may be asked to run it yourself and get some information back to Raphael and Dave. So that's what that's up there for. And I got a command line example there. Very standard stuff. Like I said, there's hundreds of them around probably. But this is what we use, and it's built with the VMS build whenever we build. So it's always there for us to use. DCL search sounds pretty common. This all started with, 2 years ago, we ran into a customer problem. They were doing backup over the network. Wasn't working. Well, we finally, after months, pared it down to a simple copy locally. So we pursued it that way. And I've continued to use that gigabyte file right there for everything I've done for like a year and a half. So I've got a baseline that I can measure everything against. The thing that we latched onto when we saw, and this was I saw this in the forum. Someone, if you're in the room, you can raise your hand if you want. They put in a loop the lexical, FYI, in a loop, I don't know, thousands of times. They said, this is horribly slow on x86 compared to Itanium. Well, that kind of piqued our interest, and we'll come back to that. And before we went too far, Christian, rewrote that in C, nothing more than doing in C the get SYI function. So we'd have a comparison between those two, if that mattered. You don't normally think of monitor as a test tool, but as you see in a few minutes, we kept looking at this and we said, this can't possibly be right. Because, I mean, between the two of us, we knew enough about the way the system should be working. And between PC tracing and sampling and monitor, we said, there's no way the system is working like this. So what is going on? So we'll talk about that too. Note on the bottom, I wouldn't generally think of anything written in DCL as a particular performance test. Simple, imprecise, but everybody does it. I mean, it's the first thing I did. So that's how we got into pursuing some of what you'll see today. And as you'll see, some of it led to something pretty interesting. I put this up here. You don't have to memorize what's up there, but you may be asked to do this, and you can run it on your system today. But you may be asked to do this and provide some information back to professional services if you're working for them. But analyze system, do some PC sampling. You can look at that. When it comes to PC sampling, you get it for free on KVM, but you've got to enable it specifically in VMware. In your CPU definition, you've got to check the box there to get the PC sampling. So what's it look like? We'll come back to search later. But if you look at this list, for those of you familiar with the system, these are the exec lists, the things that the system loads, the device drivers. You do, you get to analyze this and say, show exec. This is the list you're going to see. Now, the only thing I'll point out here is, whoops, about how many times a second now?
System runs fast.
So, the red, okay. Two things you might notice here. Base image is a pretty big number. System primitives, pretty big number. This is normal. These two images have a lot of the routines in there that everybody else in the system calls. So it would never be a big surprise to see those things showing up with big numbers. And down here, just that's memory management. Also not surprising. But if you were doing run-of-the-mill stuff, very simple stuff, and you saw anything else on this really jump out at you, that would be a red flag. After a couple pages of what I just showed, you'll see something like this, which gives you the next level down, kind of fine tuning as to what you're looking at. How many times I have to do that? You'll notice, keep OTS move in your mind for about 10 minutes from now. We have more to say about that. The thing to notice about it right here is these offsets, even though they're all different here, these are pretty close in the code. So there's something in there that you're working around all the time, and others that you would expect down here. But keep OTS moving in mind. Okay, back to the real story. I can't avoid saying your mileage will vary right here. But this is the configurations that we have where all the tests I've run are going to be reflected in the numbers. I mean, you may have a 10 gigabit NIC. You may have a 16 or 32 gigabyte fiber channel switch. So your environment could be different than this. So when you run numbers and compare them to what we have, that could be one of the variables that would make a difference. But that's what we have. The green line is fiber channel pass-through. Do a QIO. The host already knows that it can't touch this HBA. How many of you went to Paul Jacoby's? Okay, so you saw the whole 9 yards of how this gets set up. So when you're using fiber channel pass-through, the host doesn't touch it, and you literally are talking to the HBA right to the disk. That's a pretty short path, as you would imagine. The red line is what happens with an MSCP served disk. QIO, bunch of software, out on the wire, into the other system, down to 2 or 3 layers, and out to the disk. Now, you may in your head say, well, that has to be horribly slow, which a lot of people do have in their head. We'll maybe dispel a little of that notion in a minute. So that's the configuration for all these things we did in terms of fiber channel pass-through, direct access from Titanium. So I know everybody's going to read ahead here, but let's just focus on these first 2 lines to begin with. Woolco is a virtual machine, VMS virtual machine in a VMware host. And we've got like, I don't know, Rob, 12 nodes or so in LP plus 11. Some alpha, some Titanium. So we tried to match here what we think customers may start out doing. And the first 2 lines here are really to show that here are the size of the packets that we told IOF to use. And there's a couple of parameters that you can twiddle on the MSCP serving node, in this case, an Titanium system. So the real purpose here is, don't be afraid to play around, because depending on your application environment, they make a difference. Okay, so now let's look at, say, the middle 2 here. Fiber channel pass-through. It's between 2 and 3 times better. Now, there's 2 ways you can look at that. One is, if you think MSCP serving is really horrible, well, fiber channel pass-through may not be that good. The other way to look at it is fiber channel pass-through really delivers, and MSCP serving is not as bad as you might think. So why did we come to that conclusion? Bottom line, bottom line here, this is the Titanium system direct access to the SAN. And if you look at that compared to fiber channel pass-through, that's not bad. So don't be scared away from MSCP serving. It may be what you need to do. There are other parameters you can fool around with on the MSCP serve system. There are, SCS parameters. Play with them. You're going to be doing some testing anyway. Now's the chance. So the bottom line on this is the difference between fiber channel pass-through and fiber channel direct is like 5 to 10%. Having run this test hundreds of times on various systems, I don't think I've ever actually seen double figures. And I've seen it as low as like 3. So we're talking about like 3 to 8% most of the time difference. That seemed pretty good to me. Now, you may say on fiber channel pass-through, back to the picture there, well, you're supposed to be talking directly to the hardware. You are still a process being run by a host. There has to be some overhead there in a little bit.
This is with similar or comparable or the same fiber channel.
This is the same, yeah. Yep, standard stuff, accessing the same disk on the SAN. So I think this is a pretty good message to start with. Fiber channel pass-throughs does not come for free. One is for each guest in your VMware host, for each guest that wants to access SAN directly, you have to have an HBA in the host. I think there's one system we have set up where Paul and Dave Fairbanks and I all have a dual ported HBA assigned to a VM on their same host. So all of those things together work. But you have to be aware, if you want to do this, you've got to have an HBA for each guest in the host. And by doing this, you give up some of the features of VMware. Nothing to do with VMS. Yep.
Other significant things functional pass-through is that in the hypervisor, all the memory allocated to the virtual machine has to be locked into.
Yeah. Right.
So you cannot oversubscribe the hypervisor with respect to
Memory.
if you're using functional pass-through.
Right. Okay. So you give up some VMware features. This would be true of any operating system. It's just, this is the way it has to work. And if you think about, directly accessing a piece of hardware, there's no really way to maintain that in a file and move it around, have the same, worldwide IDs and all that stuff. So you give up some things here. And the bottom sentence here, you could be in a situation where you aren't exactly the master of the world, and you are just another guest on this VMware host that they say, all my guests have to be able to do vMotion because that's the way I do upgrades. I move you around to move you back. So, you may run into a situation where you have no choice but to do MSCP serving. Okay. When we started out, I hadn't even thought about, virtual disks, what I'll call local storage. Hadn't even given a thought. But then we started talking about it. I tried to look at a couple systems. So these two systems, different ones now. These are both Gen 11s. They are identical pieces of hardware, identical. And one is VMware, one is Red Hat. So first of all, on the VMware system, looked at that. Okay. Now, what's the difference between having defined one of your disks as SCSI versus SATA? Well, as Dave and I learned over a few weeks of digging around, you can read about VMware, and it will tell you that its performance is better the bigger the packet size is. And it doesn't exactly say why, but it basically says SCSI is better. End of statement. Really. So we tried to prove that, and there are the numbers. Really, those are the numbers. It's like twice as fast. Now down to the bottom one. Down to the bottom one. Okay, now we're on KVM, and we've now involved paravirtualization. VirtIO. So the first couple of times I ran this test, I said, what am I doing wrong? I mean, there's no way there could be that big of a difference, right? Well, trust me, there is. And whenever you read about paravirtualization and VirtIO, it is a bleeping winner. There's just no doubt about it. Right there. Those are real. I've reproduced that on multiple systems multiple times.
That's KVM.
This is KVM. because on KVM, we did the paravirtualization. There's a new driver called VSP driver. It requires a new driver. That's true. And the equivalent work for paravirtualization on VMware is in progress right now. Don't have it yet. The other thing we've read in a bunch of places, I have no particular proof of this yet, but they make a big deal of your I/O performance can vary vastly depending on the host KVM system. Now, I don't know whether they're talking about Ubuntu or Rocky or whatever, or whatever, but I don't know how to say much about this other than that we keep running into the words. But the bottom line in this slide is paravirtualization is a winner. Okay. We started out, okay, what's everybody do? First time they want to try something on a new system, they try copy. How fast is it? How slow is it? We kind of started that way, but we said, well, we're more interested in what's going on down in the low levels of the base operating system. Let's eliminate the file system and RMS and as many other things as we can. So we did. You remember a couple of slides ago, the difference between fiber channel pass-through and direct access from the Itanium system. It was like 5 and 10%. What's going on here? There's a 50% difference. So we went back, ran IOF, got the performance counters, and you looked at the Itanium system, you looked at the VMS system. It's the same. I mean, it's the same. We're putting the same places in the code. What happened? At first, we blamed it on DCL. We do that a lot, by the way.
You should.
Anyway, more about that later. Anyway, running perf, getting the counters, looking at it, it was the same. What's going on here? Well, back to that original trace I showed you. Now we're talking about this is a smoking gun if there ever was one. Not only that, you see numbers in double figures from these perf traces, you're looking at something real. So here we are. What's the big deal? Now, I'm going to show you what we did with Move, how we got there, but it's just one example. We'll come to that in a minute. So on Alpha, written in Alpha assembler, right? On Itanium, written in Itanium assembler. Who wants to guess what's coming next?
Oops.
Is John here? No. So I sent a mail to Reagan and I said, what the hell's going on here? And his explanation was, we started out, there's always this, what he calls the Bliss reference copy for all of this stuff. So as we from architecture to architecture, you start out with the basics, you get the darn thing working, then you figure out what you need to fix. Well, that's where we are now. So I started poking around, looking at the sources. There were 70 OTS routines. 68 of them were in Bliss 64. Okay. So I talked to John a bit, and he got his folks in Armenia involved, and we started out with OTS Move. But, I mean, we just kind of made a list out of our head. These have to be the heavy hitters. So 14 of them had been written in native assembler on x86 now, and they're in Update 2. So this was a great stride forward, I think. It didn't just, think about it. Okay, it helped my one stupid little example. This has to be massively goodness for the entire system. These routines are called all the time. Okay. Yeah.
You mentioned that folks worked on those. I think we should thank the dean for a lot of that.
There you go. The DNS. Yep, right there. I'm going to presume that we're going to go down this path a little further, and you may have more to do if you haven't already looked at it.
Sure. Just good at finding bugs.
Okay, my favorite topic today.
You're in a good mood.
Okay, before I tell you what happened and how we got there, a little review. On VAX, probe is an instruction. Give it a couple of arguments, bang, answers yes or no. Simplest thing in the world. But we've known from the beginning of x86, probe was going to be a thorn in our side, and that may be putting it mildly, because we have to emulate the whole thing. And that means per mode, per process. 4 tables to go through, per mode, per process. That's a lot of stuff to carry around. It's a lot of stuff to trudge through when you're trying to look up the answer to a simple probe. But that's the way it is. So on VAX, it's an instruction, easy to do, inexpensive. I mean, you could have tons of probes on VAX, and no one would ever know that it was being inefficiently used because it's just an instruction. It would never appear up anywhere.
It's about as expensive as a memory reference.
Exactly, right. So in those days, when in doubt, probe. I don't mean that as a knock to original implementers, but it was just the obvious thing to do. There's no reason to think about anything else. Okay. There's no instruction on x86. We have this module, emulate probe, and it does the equivalent of a probe and marching through all these tables that I just described. That's expensive, really expensive. So here we came to, we need to put into the effort to either reduce the expense of probe itself or maybe eliminate some of its use at all. We were just reminiscing a little while ago. After one of the sessions in the boot camp last fall down in Boston, Camille, Rob, Drew, Christian, and I sat in a room for like a half an hour. We said, what do we do? So we came up with a little plan, and Christian went off and kind of dug his heels in, and we actually found some things. Why am I telling you this before I tell you the answer? Back to the little command procedure that someone put in on the forum. His command procedure did a lexical $, get SY, and a loop, thousands of times. Ran it on Titanium, and he ran it on x86. Horrible, really horrible. Okay. So it just so happened that at this very time, we were implementing the changes to probe. Okay. How lucky can you get? So the top line, that may not seem like much, but a 10% improvement in probe in this dumb little get SYI program, I was surprised. If it had been 1%, that would have been pretty good. But that was staggering to me. However, down to the C program that does get SYI. Well, first of all, that's pretty dramatic right there in itself. However, this to me was staggering. To cut the execution of that little program in half just because of probe, I mean, there's a lot going on here that has to be goodness in what we changed. Has to be. And in the process of all of this, yeah, we dug into DCL a little bit. There were probably things that could be made better there, undoubtedly. But then you get into how important is the performance of DCL command procedures? Okay, that's a legit question. But there's thousands of probably, at least hundreds, if not thousands, of DCL command procedures that do real work, really, at this point in time.
There's a calculation error in your second improvement figure. It's 61%.
Hey, even better. Okay. Anyway, I don't know whether we're ever going to pursue this in DCL, but it did kind of point out that, some simple things here can make some big differences.
As the nominal DCL maintainer, I do wish to point out that the getsyi.com does a lot more work, right? No, just in terms of, because what you're asking for is, here's the text string of the thing I want, which then has to be matched into a table to turn into a getsyi call, whereas the getsyi call already knows the item it wants.
Yeah.
It's not, again, I'm not defending DCL in any way, but those are not necessarily apples to apples comparison.
Okay, granted. Yep. But again, you're back to command procedures versus something you find in an application. But it did point out something to us. And I was just blown away by the 50 or 60% improvement in this stupid little thing just because of probe. I mean, think about it. Probe gets executed all the time. You watch a running system, it is executed all the time. We have to have made the system generally better here. So what do we do? This one's fairly easy. First of all, we looked at the probe emulation itself. And that's what this was about right here. You don't have to remember the details. But you may say, well, you get the low-hanging fruit. Trust me, it wasn't that low. I mean, this took a lot of work and some good digging, but kind of found 2 or 3 areas where, we made some improvements. Did. I suspect there'll be more now that we know what to look for, where to look, how to test it. This one is a little more esoteric. This is not probe itself, but okay, we looked around other places where we used probe and we really didn't need to. Okay, found a couple. And again, I suspected as we look around a little bit more, we'll find more places where we can improve its use. Maybe not eliminate it, but cut it down. All goodness. Okay.
Oh.
No? Okay. Back in the beginning here, when we started running some of these tests, Christian and I know enough about the way the system works, and we kept seeing these things in monitor or in PC sampling. There's no way that this could happen like this. I mean, the system cannot possibly be spending this much time in what we're looking at. So back in the beginning of porting, a little ways into porting, we were probably over paranoid about taxing the host. I know that sounds stupid now, but we were worried about, do we really need the host interrupting us this often? Okay, well, still may be a valid concern. But what we finally realized, I think Chris probably figured this out eventually, is that early in the port, because we were so paranoid about not putting the host to too much work, we changed the clock tick, cut it down by an order of magnitude, as I remember. Right? Those are the numbers, right?
Yeah.
Okay, so think about this for a second. On X80s, no, on Itanium, you get pulse, and when we take a sample, and if you go sample, 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 you've got a pretty good idea of what's going on in the system. You're not missing too much. But when we did an order of magnitude longer for the sample, you go sample, sample, sample. There's a lot that can happen in between those sampling metrics. And that's what it came down to. We went back and we've changed the clock tick back to the way it is on Itanium. Now, I'll say right off the bat that when it was the way it was before, we never noticed any particular differences in the running system, only in the measurement tool. And now that we've moved it back, we still haven't run into anything that we think is funny about the running system, other than the sampling tools now tell us what we expect them to tell us.
We chased a lot of red herrings before we
No
got to
kidding.
this.
Like I said before in the other case, you may think of that as low hanging fruit, but trust me, it was not low. So good find, especially if you're in the measurement business and you're doing analysis like we are, and many of you will be. So that was all goodness as well. Okay. When I started out putting this stuff together, trying to come up with a presentation, I didn't even have this in mind, but it keeps coming up. Customers, they have this idea that, okay, I run on 8 CPUs in Titanium. How many CPUs do I need to define in my guest on x86? Legit question. However, it may possibly be totally irrelevant. I want to try to give you some data here. Again, I will encourage anyone to do some experimentation if you're in the business of trying to analyze the way your system works. So, how many of you know what UETP is? User Environment Test Program. Been around VMS forever, right? I use it a lot. It's not really what I would call a regression test by any means, but it gives you a really nice way of putting a load on the system, because you can tell it how many processes to run. It actually consists of 10 separate procedures, command procedures. So if you say, I want to run 100 loads, you get 10 of each of those 10. I almost always run 400, so I've got 40 of each of those 10 command procedures that are running. Some of them run very quickly. Some of them will run a goodly amount of time. And at the end, you've got these 10 or so, maybe 12 that run all the way to the end. And when they finish, it's over. So it's not exactly matching anybody application environment, but it's a nice mix, a lot running, some running, and so forth. So one of the systems we have, it's a DL580. It's got 3 terabytes of memory. It's got 64 CPUs, which I run on a lot. I like to push the edge now and then. So here's what happened. Test 1, 4 CPUs. MP Sync is a measure of the overhead in the operating system that is basically dedicated to managing your multiple CPUs. So beginning to end, UETP, 32 minutes. Okay. Let's change that to same exact virtual machine other than 8 CPUs. Double the number of CPUs, cut the time in half. Pretty good, right? And you only incurred 3% more of overhead. Now, granted, it's 8 CPUs versus 4, but that still looks pretty good to me. So next step.
How you look at that? Is it 3% or is it 25%?
Well, it's 3% beyond what you had before.
Well, based on yes.
Yeah. Okay. Yep.
It is a 25% increase.
Mm-hmm. So down here, 12 CPUs. Okay, really going down again, but now MP Sync is like 25%. That's still not too bad, depending on what your loads are like. Go down again. So I think the point of these first 2 or 3 here is, and again, it will depend greatly on your application environment, but experiment with the number of CPUs you have in your virtual machine. Now, there are some caveats here. Your virtual machine host has so many CPUs in it. I know it's true of VMware. I think it's true of KVM. The host will not allow you to define in an individual guest more CPUs than there are in the physical host.
Yes.
But it will allow every single guest to define up to that many. Okay, now some of that may sound a little
CPUs.
Hmm?
Unless you pin CPUs.
Well, another story.
Yeah.
Right. So here's an interesting thing. We were talking to Jan and I, Magnus and I were talking to a customer, got to be a couple of years ago. He purposely, I'm going to say, overcommits the number of CPUs he defines in his guests compared to what's in the physical host. So let's say you had, I don't know, 32 CPUs in your host. He intentionally defined the number of CPUs cumulative in his guests to be more than that number. It may seem a little ridiculous, right? He knew his application environment so well that the percentage of time in which all of the guests were running flat out was like 2% of the time. So he was more than willing to give up that 2% of the time and be overcommitted in the CPUs for the other 98% of the time in which he was able to take advantage of all the CPUs in the system. I thought this was really interesting, but you really have to know what you're doing to do that. And easily measurable, with the idea of overcommitting the number of CPUs in your guests is not maybe as far-fetched as you think. So that's my bottom line message there. Oh, good.
Hey, Claire.
Yep.
Back again. What happened between test 5 and 6?
I haven't gone there. But that's a very good question. I figured that you get down to like 16, not many people are going to be that interested. But yes, it would be very interesting to know us. And this is a system where I often run with 64 CPUs, and that would be even more interesting.
Number of what's the CPU physical configuration? One chip as a core as opposed to 2 chips with N over 2 cores.
Can I go backwards a long ways? I think I have the answer without having thought about it.
I could have missed it.
There's my system right there.
So it's 8. Okay, you didn't go over 1 core, but the VM.
But this is all virtual.
This is all virtual.
Yeah. I'm just trying to think out loud. Is there a possibility that between the last 2 rows you end up with a different L3 cache?
Haven't looked into it.
On the DL580.
This is the 580.
2-socket machine.
Yep.
That's what I thought.
Yep, it is.
It said 64 at the bottom.
So the question is which sockets had which CPUs? And no, I'm not being facetious.
No, I know.
It's the last.
Yep.
The debounce is what was the actual population?
Mhm.
Because an L3, L1, 2, and 3 are on a L1 and 2 are on per core.
Yep.
L3 is per chip.
Mhm.
And if you have a split between the 2 chips, you will get a cliff.
Your mileage may vary.
Claire, I happen to know for a fact that the DL580 has routes at the hardware level, at the VM level. They don't pass them through to VMS. We can't see them. But depending on what VMware or what the hypervisor is doing with routes, we could be seeing some effects.
Interesting questions, of course, but I figured it wasn't practical to go beyond the 16, so I did.
The other follow-on is newer generation chips are having high and low performance cores.
Mm-hmm. Yes.
That may be a complicating factor.
Could be. But there's no single answer to how many CPUs do I need in my guest compared to what I run on my Itanium systems. Try it. Bring it up, change them. It's easy. Figure out what is best for your environment. You may find out something interesting. And I guarantee you'll learn a little bit about how your environment runs just by doing these tests. Okay. We did a lot of work to make Fiber Channel faster work, as we heard in Paul's presentation the other day. Well, now it was, show me the money. Very encouraging for the first pass of doing tests like this. Very encouraging. And I'm looking forward to parent version on VMware, because that'll make a huge difference there too, I think. Things we talked about, probe improvements, general goodness, and has to be in a lot of ways. Clock tick change, good for measurement. We needed it. And the OTS routines, also really good. Probably more to come, but they also have to affect a lot of things. experiment with a number of CPUs. If you have a question, try it. Try 4, try 8, see what happens. Maybe it doesn't make any difference. Maybe it does. Mentioned once, we keep reading this, but I haven't done enough testing to actually prove it makes any difference. But there is one thing I want to do. Back in the very early slide where we had 3 columns, size of IOF, packets were 1024, 2048, 8196. I need to go back and I need to add 3 columns on the left for smaller size packets, 64, 128, 256, whatever. Because we keep reading that there are differences based on packet size between SCSI and 7. Let's find out what it is.
In a similar vein, the search command benchmarking,
Mm-hmm.
RMS locking and buffering pack.
There's lots of things.
Huge performance difference depending on configuration and how things are allocated and such.
Okay. Yep.
And complicated by storage arrays which do their own thing behind your back.
Granted. Yep. Oh, one thing I didn't mention is when I do these tests, whatever disk I'm going to, I have XQP and XFC disabled, just so I can run the test over and over again and have a benchmark.
But you've got the controller caches around and the other things which can distort you fairly well.
Right. So the whole purpose in a lot of this is the bottom line here. Now that we're beyond today and this week, I've been working with Raphael and Dave. We want to put together an informational paper that we can publish to, community for people who are asking these sorts of questions. Don't know quite how to approach it yet, but I think that what we'll generally say is, here are the findings that we have on this configuration. Here are some real numbers. Go do it yourself. And if you find out something that is drastically different than what we found out, one, we really want to know about it. And that's what it's going to take for us to help you. So I'm using Dave here as a test case because I've given him IOF. He's given it to a customer. They filled out the rap sheet. So we kind of got a field test of using this with real customers already. We'll get that to be more formalized. And then when someone calls up, they've tried something, doesn't work very well, or they think it won't work very well, we have a way for them to give us data that will exactly match the way we've done what we got for our numbers. I'm not surprised that they'll be a little different, but at least if a customer starts out with data that kind of looks like ours or some of these little tests that we have, and then all of a sudden this application environment comes back with some more numbers, at least we know that the baseline system that they have looks something like ours and should be comparable. Jim?
History question. You talked about this when you did Fiber Channel. I apologize. Did you ever put in the effort to try and go find IO hack?
We haven't. We got a couple more things like that, but I just picked this one as a starter. Yeah, I mean, part of our CTM test, we use IO Hammer, which I also run occasionally. We've got others. We got file system as well. But it'll be interesting for some other tools as well. Yep. We have it.
Because for a while, it was amongst the missing the HPE to BSI transition.
Okay. Interesting. Okay. Excellent. I'm willing to take what do I do here? First of all, is what you heard today useful? What else would you like to see? We have more to do, for sure. Next kind of on my hit list are native builds are at the point where I believe I can start doing some serious testing like I've been doing with these other systems. I've been running native build for quite a while. So is John, so have a few others. Paravirtualization on VMware in progress. And iSCSI. Once that gets to the point of a place where I can get, seriously enthused about pounding on it, that will be next. And what I didn't have up here is OCI. I need to get set up on OCI so I can start doing some of these things similar to what I've done here. in the cloud. So that's kind of the four next things up here. So questions about what we talked about today, things, talk to me. If you want to get involved in professional services, talk to Raphael, because we're putting the wheels in motion to get all of this stuff out to people so we can help them. You want to add to that at all? Or?
Yeah, so,
Okay.
So we, basically our idea is to try to get, let's say, this.
Yep. Okay. I mean, my stupid little command procedure that I use to run IOF, they took it, unified it a little bit, put a real interface on it. And that's what you want to add to that, Dave? I mean, you gave it to some.
I stole it, puffed it up and sent it away.
Yep. And we have real data already back from a customer. I haven't had a chance to look at it yet, but we kind of got the field test of this in motion. So
I know I sent you the numbers.
Yep.
Yeah.
So anyway, this is as much a plug for here's how we attend to approach helping some customers. Because there are enough of them now who have enough of an application environment ported that they're ready to do some real testing and not just this little tiny testing like we can do ourselves, and we can't duplicate what they have to show. Okay, so this is a big plug for professional services, because this is how you're all going to do this. Going once, going twice. Thank you very much.